see over here, we are talking about the zero order reaction. So the meaning of zero order reaction. Suppose let's say we have a reaction, simple reaction. A reactant is converting into product. Reactant is converting into product. The rate of this reaction is proportional to the zero exponent of the concentration of reagent. That means rate is K times R raised to 0. Concentration of reactant is, okay, here we write it like this and raised to 0. So that's what they have written. Rate equal to, but rate को हम ऐसे भी लिखते हैं ना, minus dr by dt. That is K into R raised to 0. And anything raised to 0 is 1. So K into 1 equal to K. That means rate equals to, which is minus dr by dt equals to K. If we bring dt on the other side, then minus dr equals to K dt. On integration, minus dr equal to integration of K dt. Integration of dr, and also we'll do one more thing. Here, minus sign will change from here to the other side. So dr, integration of dr equal to minus integration of K dt. Correct. Integration of dr is r. Integration of K dt is kt along with minus sign, and c is integration constant for both the integration. एक ही बार डालना होता है. So r equals to minus kt plus c. Okay. Let's try to find out the value of c. We have reached to this point. Now we would like to find out the value of c. C की वैल्यू किस तरह से फाइंड करेंगे? Suppose at time t equal to 0, when we just begin our reaction, at time t equals to 0, obviously अगर हम इसकी वैल्यू यहाँ पे डालेंगे, see at time t equal to 0, concentration R is basically R0. अगर टाइम t 0 है तो हमने जो चालू किया कॉन्सेंट्रेशन, उस टाइम पे जो रिएक्टेंट का कॉन्सेंट्रेशन वी कॉल इट R0, इनिशियल कॉन्सेंट्रेशन. सो इफ यू पुट इट ओवर हियर, दैट मींस कॉन्सेंट्रेशन R0 इक्वल्स टू माइनस K into 0 plus C minus anything into 0 is 0. That means this part gone. C equals to क्या मिला आपको? R0. So at time t equal to 0, C equals to क्या मिल रहा है आपको? R0. That's what I explained you over here. Did you see that? That means R0 equals to C. And instead of C now, what we are going to write down is R0. So our equation becomes like this. R equals to minus KT plus R0. R equals to minus KT plus R0. And if we compare this reaction with y equals to mx plus c, we compare this equal to y equals to mx plus c. Y represents vertical variable, variable on vertical axis. X represents horizontal variable, variable on horizontal axis. So x, देखो यहाँ पे दो ही वेरिएबल है, यहाँ पे कॉन्सेंट्रेशन ऑफ R चेंज होता जाएगा जैसे टाइम t चेंज होता है. सो दो वेरिएबल, टू वेरिएबल इक्वेशन. Okay, so y has to be on vertical axis. That means concentration of R has to be on vertical axis, and concentration of X has to be on horizontal. If we plot a graph where time we are taking on horizontal axis and concentration of R we are taking on vertical axis, then this equation will represent a straight line. It will represent a because it does match the straight line y equal to mx plus c form. Correct or not? Yes or no? Are you following me? Not only that, if we compare further, value of c is always y-intercept. That means यहाँ पे y intercept जो हमको मिल रहा है, it has to be r0 because c is over here is r0 and m which is over here minus k will represent slope. Correct or not? So we have interpreted this zero order reaction in slope intercept form of equation. Correct or not? आपको समझ में आ रहा है क्या? That's the one thing. So that's what they have written. Now if we draw a graph of concentration R versus time t, then straight line will be obtained and the value of slope will be equal to the negative value of k, that is minus k, and the value of the intercept will be R0, that is the concentration at 0 time equal to the initial concentration R0. Is this understood? Are you following me? See, so one thing we got is slope intercept. We got that. Now with equation which we had R equal to minus kt plus R0. If we bring R0 to the other side, then minus kt equals to R minus R0 or kt equals to R0 minus R. और kt को यहाँ पे लेके आओ, R को सामने लेके जाओ, and kt equals to R0 minus R or k equals to R0 minus R by t. So we get the value of constant k by using this formula 0. बराबर, तो ये दूसरा है. And अगर R की जगह पे आप RT लिख दो जनरल टर्म. Now if we write the values of reactant at any time t equals to RT, then equation can be as k equal to R0 minus RT by t. Correct or not? If we continue further, half-life period of a reaction. Half-life period of a reaction means the time required for the concentration of the reaction in the reaction to become half. How much time it will require for initial concentration to become half. Okay. And the half-life period of radioactive element is defined and is expressed as t half. Okay, if you put the value of concentration at time t half in the equation, actually at time t half, according to definition, RT becomes half of R0. Okay. So RT becomes half of R0. And here, this equation, if I write in different way, so T equals to R0 minus RT upon K. Now, but RT की जगह पे we may write half R0, so R0 minus half R0 upon K. T की जगह पे अगर T half लिखो, at time T equals to T half, at time T equals to T half, RT equals to half R0. So, at T half, R0 minus half R0 upon K. But R0 minus half R0 equal to half R0. That means R0 by 2. So T half equals to R0 by 2K for zero order reaction. For zero order reaction. It is apparent from the above that the half-life period T half for zero order reaction is directly proportional to initial concentration. T half is proportional to R0. Correct? Is it fine? अगर आपको जीरो ऑर्डर का डेरिवेशन पूछते तो यहाँ तक लिखना है 3 से 4.